ವೆರಿ ಗುಡ್ ಮಾರ್ನಿಂಗ್. ಆಲ್ರೆಡಿ ನಾವು ಮೆಟಲ್ಸ್ ನಾನ್ ಮೆಟಲ್ಸ್ಗೆ ಸಂಬಂಧಪಟ್ಟಂತೆ 1 ಮಾರ್ಕ್ ಕ್ವಶನ್ಸು ಮಲ್ಟಿಪಲ್ ಚಾಯ್ಸ್ ಕ್ವಶನ್ಸನ್ನು ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ. ಹಾಗಾದರೆ ಈಗ ಏನು ಮಾಡಬೇಕಪ್ಪ ಅಂದರೆ 2 ಮಾರ್ಕ್ ಕ್ವಶನ್ಸನ್ನು ಡಿಸ್ಕಸ್ ಮಾಡಬೇಕು. ಹಾಗಾದರೆ ಹೆಚ್ಚು ಟೈಮನ್ನು ವೇಸ್ಟ್ ಮಾಡಿದ್ರೆ ಸ್ಟಾರ್ಟ್ ಮಾಡೋಣ. ವಾಟ್ ಆರ್ ಮ್ಯಾಲಿಯೇಬಲ್ ಆ್ಯಂಡ್ ಡಕ್ಟೈಲ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಮೆಟಲ್ಸ್ ಅಂತ ಕೇಳಿದ್ದಾರೆ. ವಾಟ್ ಆರ್ ಮ್ಯಾಲಿಯಬಿಲಿಟಿ ಆ್ಯಂಡ್ ಡಕ್ಟಿಲಿಟಿ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಮೆಟಲ್ಸ್. ಹಾಗಾದರೆ ಮ್ಯಾಲಿಬಿಲಿಟಿ ಯು ಆಲ್ರೆಡಿ ನೋ what metals bitten into a thin sheet, it is called as a malleability. Oda metals are bitten into thin sheets, those are called as a what malleable. Okay, and whatever the metals they have a property of a malleable, those are malleability. Then ductility, metals drawn into thin wire, metals drawn into thin wire, example copper wire, aluminum wire, or maybe what gold wire. Okay, but if we beat them into thin wire, okay, by applying a force we can able to convert them into a wire, then it is called as a ductility. Metals are drawn in a thin wire, okay, that's called as a ductility. Highly malleable, okay, highly malleable, highly ductile. Okay, gold, silver, aluminum. Gold, silver, these are the metals what highly malleable and highly ductile. Copper also, okay, ductile. Which physical properties are used in the following situation? Gold is used to make ornaments. Why gold is used to make ornaments? Because it's it has a capacity, it has a high malleability and ductility, and lustrous surface also, shiny surface is there. That's why they are used to make ornaments. And nickel is used strings and guitars, because we can able to draw them in a thin wire. Ductility properties there for nickel, that's why they are used to make a strings and guitars. And they are sonorous. Sonorous means they have a capacity to produce, with the help of vibration, they produce a sound. That's why nickel is used in strings and guitars. Name any two metals that react with the cold water very quickly. Write the product formed when these metals react with the cold water. For example, potassium and sodium are highly reactive elements. They react with the cold water also. When potassium reacts with the water, okay, it gives a potassium hydroxide with liberation of a hydrogen gas. Same way, okay, maybe in your class ನಿಮ್ಮ ಸರ್ ಏನು ಮಾಡ್ಬೋದು ಅಂದರೆ ನಿಮಗೆ ಸೋಡಿಯಂ ಮತ್ತು ಪೊಟ್ಯಾಷಿಯಂ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮಾಡಿ ತೋರಿಸಿರ್ಬೋದು. ನೈಫ್ಗಳಿಂದ ಸೋಡಿಯಂ ಪೀಸನ್ನು ಕಟ್ ಮಾಡಿ ನೀರಲ್ಲಿ ಹಾಕಿ, ಹೌದಾ, ಅಂತ ಸೌಂಡ್ ಮಾಡುತ್ತೆ. ಸೌಂಡ್ ಮಾಡ್ತಾ ಹೈಡ್ರೋಜನ್ ಗ್ಯಾಸನ್ನು ಲಿಬರೇಟ್ ಮಾಡುತ್ತೆ. ಅದನ್ನು ಆಲ್ರೆಡಿ ಅವ್ರು ಏನು ಮಾಡಿರ್ಬೋದು ಅಂದರೆ ನಿಮ್ಗೆ ತೋರಿಸಿರ್ಬೋದು. ಹಾಗಾದರೆ ಅವ್ರು ಮಾಡಿ ತೋರಿಸಿರ್ಬೋದು. ಆ ಅಂತ ಸೌಂಡ್ ಮಾಡ್ತಾ ಏನು ಬಿಡುಗಡೆ ಆಗಿರ್ತದಪ್ಪ ಅಂದ್ರೆ ಒಂದು ಹೊಗೆ ರೀತಿ ಫ್ಯೂಮ್ ಬಿಡುಗಡೆ ಆಗಿರ್ತದಲ್ಲ, ಅದು ಹೈಡ್ರೋಜನ್ ಗ್ಯಾಸ್. So sodium reacts with water, it gives a sodium hydroxide with liberation of a hydrogen. Very simple reaction. So ಆಮೇಲೆ ನಾನೇನು ಮಾಡಿದ್ದೀನಪ್ಪ ಅಂದರೆ ಆಲ್ರೆಡಿ ಶಾರ್ಟ್ಸನ್ನು ಮಾಡಬೇಕಾದ್ರೆ ಫಿಸಿಕಲ್ ಪ್ರಾಪರ್ಟೀಸ್ ಆಫ್ ಮೆಟಲ್ಸ್ ಮತ್ತು ನಾನ್ ಮೆಟಲ್ಸ್ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ದೀನಿ, ಹೌದಾ. ಕೆಲವು ಜನ ನೋಡಿರ್ಬೋದು. ಹಾಗಾದ್ರೆ ಡಿಫ್ರೆನ್ಸ್ ಬಿಟ್ವೀನ್ ಮೆಟಲ್ಸ್ ಆ್ಯಂಡ್ ನಾನ್ ಮೆಟಲ್ಸ್ ನೋಡ್ಬೇಡಣ. ಓಕೆ, ಮ್ಯಾಲೇಬಲ್ ಪ್ರಾಪರ್ಟಿ ಆಫ್ ಡ್ರಾನ್ ಇಂಟು ಥಿನ್ ಶೀಟ್ಸ್, ದಟ್ಸ್ ಕಾಲ್ಡ್ ದ ಮ್ಯಾಲೇಬಲ್. ಮೋಸ್ಟ್ ಮ್ಯಾಲೇಬಲ್ ಮೆಟಲ್ಸ್ ಆರ್ ಗೋಲ್ಡ್ ಆ್ಯಂಡ್ ಸಿಲ್ವರ್. ನಾನು ಆಲ್ರೆಡಿ ಹೇಳಿದ್ದೀನಿ. ನಾನ್ ಮೆಟಲ್ಸ್ ಆರ್ ನಾನ್ ಮ್ಯಾಲಿಯಬಲ್. Then metals are ductile. Metals are ductile. Most ductile element or ductile metal is gold, because 1 gram of gold we can draw into thin wire up to 2 kilometers. That's a highly ductile metal is gold. Then non-metals, non-ductile. Then metals have a shiny surface, that's why they are called as a lustrous, have a shiny surface. Okay, non-metals, non-lustrous, but exception is there. Okay, exception except iodine and graphite, because iodine also has a shiny surface, graphite also shiny surface. Next, metals, good conductor of heat and electricity. Metals are good conductor of heat and electricity. Non-metals, non-conductor of heat and electricity, but there also one exception is there. What is that? That is a graphite, conductor electricity. Graphite is a good conductor of electricity. Next, metals sonorous, produce a ringing sound. How they produce a ringing sound? By vibration. Okay, metals are used to make a bells, strings of musical instruments. That's why metals are sonorous. Non-metals are non-sonorous. Metals are a solid liquid. What metals are at a solid state, always they are at a solid state, but one exception is there. Okay, liquid metal is a mercury. It's a exception. It's what exception? Which one? Liquid metal is a mercury. Then non-metals are brittle except diamond. Non-metals are brittle except diamond. Found as a solid or gaseous or liquid in the form. And what liquid non-metal? Okay, liquid non-metal. It's a bromine. Liquid non-metal is a bromine. Then what metals are hard, but except sodium and potassium. Why? Because sodium and potassium are so soft, we can able to cut them with the help of knife. Okay, that's why it's an exception. Which one? Sodium and potassium. Metals are hard, but exception sodium and potassium, because we can able to cut them with the help of knife. Then non-metals, they are brittle except diamond. I already told for you. Then metals are metals have a high melting point and boiling point. Non-metals less melting point and boiling point. Then for a metals example, gallium, cesium, very sorry, what iron, copper, what then zinc. These are the what example for metals. For high melting point and boiling point, one exception is there. What is that? Gallium and cesium. What both these are metals, but they have a low melting point and boiling point. Okay, and non-metals less melting point and boiling point, I already told for you. And example for metals I told for you: iron, gold, silver, copper, lead. Okay, these are examples for metals. Non-metals: carbon, nitrogen, oxygen, hydrogen. These are all non-metals. Write any two difference between chemical properties of metals and non-metals. Chemical properties difference they asked: metals and non-metals. Metals reacts with oxygen to give a basic oxide. Metals reacts with the oxygen. For example, magnesium reacts with the oxygen. What it gives? It gives a magnesium oxide. What it gives? It gives a magnesium oxide. It is a basic oxide. It is what? Basic oxide. Then non-metals. Non-metals reacts with oxygen to give a acidic oxides. Example, carbon reacts with the oxygen. What it gives? It gives a carbon dioxide. Carbon dioxide is a acidic oxide. Okay, this is a chemical property. Then metal reacts with water to give a hydroxides or oxides. Metals reacts with the water. For example, sodium reacts with the water. What it gives? It gives a sodium hydroxide. Sometimes they give a hydroxide, sometimes they give a oxides. Okay. Then non-metals do not react with water. Non-metals do not react with the water. Okay. Remember. Then metals reacts with acid to form salts and hydrogen. Metals reacts with the acid. For example, zinc reacts with the hydrochloric acid. What it gives? It gives zinc chloride with liberation of hydrogen gas. Means whenever the metals reacts with the acids, what they give? They give salt and hydrogen. Okay. Non-metals do not react with acid. High reactive metals displaces less reactive metals. For example, which one? Aluminium, or it may be what? Copper, or it may be which one? Zinc. If you take a zinc, it reacts with the iron sulfate. It displaces iron because zinc is more reactive than iron. That's why it gives us zinc sulfate with separation of iron. With separation of what? Iron. This is a displace reaction. That's why metals reacts with the non-metals. High reactive metals displaces a less reactive metal. High reactive non-metal displaces a less reactive non-metal. High reactive non-metals displaces a less reactive non-metals. Then metals reacts with the non-metals to form ionic compounds. For example, which one? Magnesium. Magnesium, it's a metal, reacts with a non-metal chlorine. What it gives? It gives a magnesium chloride. Okay, it's an ionic compound. It's a what? Ionic compound. Non-metal reacts with a non-metal to form a covalent compound. For example, which one? Oxygen reacts with the oxygen. It gives a oxygen atom reacts with oxygen atom. It gives oxygen molecule. That's why in between oxygen, which what bond is there? Covalent bond is there. You already know the difference between covalent bond and ionic bond. Sharing of electrons occurs in covalent bonds. Okay, and exchange of electrons, giving and taking of electrons occurs in where? Ionic compounds. Maximum all salts are ionic compounds, and what all organic materials are what? Covalent compounds. Okay, carbon and its compounds, whatever we discussed, they are what? Those are all what? Covalent compounds. Then metals are electropositive, non-metals are electronegative. For example, sodium Na plus, electropositive. Okay, non-metal chlorine Cl minus, it's electronegative. Does a chemical reaction takes place when zinc is added to ferrous sulfate solution? Justify your answer. Does a chemical reaction takes place when zinc is added to ferrous sulfate solution? Yes. Why? Because zinc is more reactive than iron. Zinc displaces iron. Zinc reacts with which one? Iron sulfate. What it gives? It gives a zinc sulfate with a separation or a displacement of a iron. Okay, we wrote a reaction also and reason also. What will you observe when some silver pieces are put into green colored ferrous sulfate solution? Some silver pieces are put into green colored ferrous sulfate solution. Reaction will not take place. Silver is less reactive than iron. Okay, if we see a silver and ferrous sulfate, ferrous means iron sulfate. Okay, silver is a less reactive than iron. That's why displacement reaction will not occur. Displacement reaction will not occur. Then what? Reaction will not take. Silver is a less reactive than iron. Next, copper coin is kept immersed in a silver nitrate solution. Okay, for some time. Copper is being a more reactive than silver. That's why what copper displaces a silver nitrate solutions from silver, there will be deposited on silver on copper coin. On which coin? Copper coin. Solution will turn blue color. The change of a color of the solution occurs here. It will turns into blue. Okay. The next. Write a chemical equation that shows aluminum oxide reacts with acid as well as base. Okay, chemical equation that shows aluminum oxide reacts with acid as well as a base. Aluminum oxide Al2O3. Okay, base NaOH. What it gives? Aluminum, sodium aluminate NaAlO2 with a byproduct of a water. Okay, write a chemical equation that shows aluminum oxide reacts with the acid. Aluminum oxide reacts with acid as well as a base. First they given, because aluminum oxide is a amphoteric oxide. Okay, sometimes it acts like a acid also, sometimes it acts like a base. Whenever it reacting with base, it acts as acid. Okay, here they given sodium aluminate as a product with water, and whenever it is reacting with acid, it acts as a base. Okay, what it gives? It gives aluminum chloride with water. Amphoteric in nature because of this only. Write the balanced equation for the following. Magnesium reacts with a dilute hydrochloric acid. Magnesium Mg, it reacts with the hydrochloric acid HCl. What it gives? It gives a magnesium chloride with liberation of hydrogen gas. Same. Aluminium when heated with air. Okay, aluminium reacts in air, oxygen is present, it reacts with air and it gives aluminium oxide Al2O3. How aluminium and magnesium reacts with water? How aluminium and magnesium reacts with water? Write a balanced chemical equation. They asked. Aluminium reacts with the water. What it gives? It gives aluminium oxide with liberation of a hydrogen gas. Okay, Al2O3. Here how many aluminiums are there? 2. That's why we took here 2. Then how many oxygens are there? Here 2. Okay, to balance the oxygen, here only 1 is there, we took here 3. If we take it 3 here, aluminum oxide is balanced, but what hydrogen is imbalanced. To balance that one, here how many hydrogens are there? 3 2 is 6. Okay, here also we take a 3. If we take a 3, what reaction is balanced. Same, magnesium reacts with the water, it gives a magnesium hydroxide with the liberation of hydrogen gas. Okay, magnesium, here also one is there, here also one is there. Okay, then Oxygen and hydrogen, if we see, oxygen and hydrogen, if you see here, two oxygen and two hydrogens are there. Here two hydrogens are there, 2 plus 2, 4 hydrogens are there, and two oxygens. That's why to make a balance, that one we took here 2, 2 2s are 4, 4 hydrogen finished, 2 oxygen, that also finished. In the formation of compound between two atoms A and B, A loses 2 electrons and B gains 1 electron. What is the nature of a bond between A and B? Suggest the formula of a compound formed A and B. Okay, what is the nature of the bond between A and B? It's an ionic bond, because exchange of electrons. Okay, whatever A is there, that donating electrons and B gaining electrons, because of exchange of electrons, bond is formed. Then it is which bond? Ionic bond. Then what first element has a capacity to donate 2 electrons, and second element only able to receive 1 electron. Then whatever the reaction, whatever the what formula forms, that's a AB2. Why AB2 means? I will give example. Magnesium, in its outermost shell, 2 electrons are there. They are capacity to donate those 2 electrons. It reacts with chlorine. Chlorine capacity to accept 1 electron. Accept 1 electron. That's why only 1 electron if it accepts, means another one remains in where magnesium. That's why it reacts with 2 chlorine to donate these 2 electrons. To donate these 2 electron, what it gives? It gives a magnesium chloride, MgCl2. That's why here AB2. A is a magnesium, B is a chlorine. Its formula AB2. What are ionic compounds? Mention its properties. Compound formed by a transfer of electrons from metals to non-metals, it is called as a ionic compound. Then ionic compounds are crystalline solid. We already seen in our kitchen, whatever the salt is there, okay, touch that salt, how it's in nature, it's a crystalline solid. Then whenever they are in a molten state, they are the bad conductor of electricity, which are those ionic compounds. But whenever they are in solution state, they are good conductor of electricity. That's why conduct electricity, do not conduct electricity in molten state. They conduct electricity. Molten means it's a semi-liquid. Okay, in molten state they conduct electricity, but in solid state they do not conduct electricity. They are soluble in water. Completely they dissociate or they dissolve in water. And their melting point and boiling points are high. Why? Because if you take a small amount of salt in a spoon and start to heat, it breaks into pieces, but it doesn't melt down. It doesn't come to liquid state. Why? Because its melting point and boiling points are very high. These are the some properties of ionic compounds. What are those? First one, transfer of electrons from metals to non-metals. They are crystalline solids, conduct electricity in a liquid state or molten state. They are soluble in water. Their boiling point and melting point are high. Show the formation of sodium oxide and magnesium oxide with example. Okay, sodium 281, its electronic configuration. In outermost shell 1 electron is there. That electron what sodium capable to donate. Next, in oxygen 26, its electronic configuration. That's why it needs another 2 electrons to get a octet state. And magnesium its electronic configuration is 282. In outermost shell it has 2 electrons. Those electrons are metals donate electrons. That's why the outermost shell, whatever the electrons are there, those are donated. That's why in Mg plus 2 electrons are there. The formation of sodium oxide and magnesium oxide can be written as follows. See, for example, sodium, in outermost shell only 1 electron is there. Here also 1 electron is there. But oxygen, whenever it reacting with oxygen needs 2 electrons. That's why it reacts with 2 sodium. It reacts with 2 sodium, 2 Na plus and 1 O minus, and what it gives? Na2O. Its formula. This is the formation of sodium oxide. That same way, magnesium in outermost shell 2 electrons are there. Okay, those are what donated, and in oxygen 2 electrons are required. That's why 1 magnesium reacts with 1 oxygen. Magnesium donate 2 electrons, oxygen accept to those two electrons. Now what is its formula? It's a MgO. Here if I Na2O, here MgO. I think you understood. Okay, not understood means watch my live class, whatever done in Kannada medium. A student set up an electric circuit shown in figure. He placed a metal to be labeled in the circuit between A and B. Here A and B are there. This is the what one small electric circuit is there. It's switch, bulb and battery, electric wires. Okay, in between A and B he placed a metal. Then what does the bulb glow? Yes, definitely the bulb glows. Why? Because we already studied the properties of metals. Metals are good conductor of electricity. That's why bulb glow. Yes, the bulb glow. It indicates that metals are good conductor of electricity. It is because rubber is it. Next one. Why are electric wires coated with rubber like material? Why? Because rubber is an insulator. It does not allow current to flow through it. Okay, it does not allow current to flow through it. If we touch that wire, okay, nothing shocks or electric mishaps will not occur. That's why the electric wires are coated with plastic or rubber to avoid harmful things. Okay, to avoid wastage of electric current. Then next, Anita observed that blue color of aqueous copper sulfate solution changed to pale green by inverting a metallic rod for some time. Identify the metal rod in contact with copper sulfate. Mention the types of reaction. See, Anita observed blue color of aqueous copper sulfate solution change the pale green by inverting a metallic rod. By inverting a metallic rod for some time. Okay, why the copper sulfate solution turns into a pale green means it reacts with the iron. It reacts with the iron. Iron is a high reactive than copper. That's why it displaces copper from copper sulfate solution. Next, here iron reacts with the copper sulfate solution. What it gives? It gives a iron sulfate and it displaces copper because iron is a more reactive than copper. Okay, here blue colored solution is there. It turns into which color solution? Pale green solution because it turned what the product is changed. Product is iron sulfate with a displacing a copper. That's why it is a displacement reaction. Which reaction? Displacement reaction. Next, 3 marks question. Strip of a zinc, iron, magnesium, copper added to test tube A, B, C, D. Some quantity of ferrous sulfate solution is added to these test tube. In which test tube chemical reaction will occur? Why? Write the chemical equation for the reaction takes place. ಅಂತ ಒಂದು ಕ್ವಶನ್ ಕೇಳಿದ್ದಾರೆ. ಹಾಗಾದರೆ ಟೆಸ್ಟ್ ಟ್ಯೂಬ್ A and B. What in test tube A and C? A is a zinc, another one is a magnesium. Okay, in test tube A and C reaction occur. Zinc and magnesium is more reactive than iron. These are what? More reactive than iron. That's why they displace iron. That's why displacement reaction occurs. See, for example, what they ask, A is a zinc, A is a zinc, C is a magnesium, B is iron is there. And which solution we took here? Ferrous sulfate solution means it's iron sulfate solution only. That's why iron and copper will not react because copper is less reactive than iron. That's why it not displaces the iron. And iron will not displace iron because the reactivity is same. That's why zinc reacts with the iron sulfate solution. What gives zinc sulfate? With separating iron. In next case, magnesium reacts with the iron sulfate. Magnesium reacts with the iron sulfate. What it gives? It gives a magnesium sulfate with displacement of iron. Displacement of iron. Why? Because zinc also and magnesium are more reactive than iron. That's why they given a reaction also. Okay, zinc reacts with iron sulfate. What gives good? Zinc sulfate. Iron is separated. Magnesium is also high reactive than iron. That's why it reacts with iron sulfate, and what it gives? It gives a magnesium sulfate and a separation of iron. Write the balanced equation of the following chemical reactions. Write the balanced equations of the following chemical reactions. First one, zinc reacts with a dilute hydrochloric acid. Zinc reacts with a dilute hydrochloric acid. Then zinc is a high reactive and the hydrochloric acid is also strong acid. Both they react. What they give? They give a salt, zinc chloride, with liberation of hydrogen gas. Next, sodium reacts with a cold water. Sodium reacts with a cold water. It gives a sodium hydroxide with liberation of hydrogen gas. Okay, this reaction already we discussed. It's repeated. Then copper also reacts with a oxygen. Whatever the oxygen present in environment, and it turns into copper oxide. Okay, the copper turns into slightly back because of copper oxide. Next, show the formation of sodium chloride and magnesium chloride with the help of electron dot structure. Identify the ions present in these compounds. Okay, this is a very important question for our exam point of view. 2-mark question. See, I already told for you what sodium. Sodium's electronic configuration is 281. In its outermost shell, 1 electron. It's a free, capable to donate. That's why whenever it donates that 1 electron, our sodium turns into sodium ion. Then chlorine, it's a non-metal. Its electronic configuration is 287. In its outermost shell, if it receive, it gains 1 electron, then it gets octet state, 288. Okay, it's called as a chlorine anion. Chlorine anion. Same way, what sodium, in its outermost 1 electron is there. In chlorine, its outermost 1 electron less is there. That's why sodium donate 1 electron to chlorine, and it gives a sodium chloride. What it gives? A sodium chloride. By what? Exchange of electrons, ionic bond is formed here. Next, magnesium. Magnesium, its electronic configuration. Magnesium's electronic configuration 282. In its outermost shell, how many electrons are there? 2 electrons are there. Those 2 electrons are set to free for donating. Set to free for donating. And I already told for you chlorine. Okay, chlorine electronic configuration 287. In its outermost, it requires 1 electron. It requires 1 electron. That's why 1 magnesium reacts with 2 chlorines by donating those 2 electrons. One electron for 1 chlorine and another electron for another chlorine, and it gives what? MgCl2. What it gives? MgCl2. Because magnesium valence is 2, chlorine's valence is 1. That's why 1 magnesium reacts with 2 chlorine atoms. 2 chlorine atoms. Okay, and dot structure is given here. Because in outermost, how many electrons are there? 7. Okay, and 1 is filled with magnesium, and here also 7. 1 is filled with magnesium. So Na plus Cl minus, what they give? NaCl, like that only. MgCl2, Mg plus 2, it's a cation, and Cl minus, it's an anion. Explain the formation of sodium chloride. The bond formation in sodium chloride, NaCl. Sodium chloride is an ionic solid. The general electronic configurations are sodium 281, chlorine's electronic configuration 287. Sodium is the excess of 1 electron to attain octet configuration. Chlorine has 1 electron less to attain an octet configuration. So the excess of 1 electron is transferred to chlorine to atom from sodium atom, and thus an ionic compound is formed. Due to the transfer of electrons, chloride being a more electronegative atom than sodium tends to attract the shared electrons pair towards itself. Thus the sodium chloride has Na plus and Cl minus atoms. Chloride attains a octet configuration by gaining on electron. Sodium attains octet configuration by losing the electron. Thus ionic solid sodium chloride is stable. Okay, now we are going to discuss a 4-mark questions. Write a balanced equation of the following. For example, magnesium burns in air. Magnesium burns in air means it absorbs environmental oxygen, and what it gives a product? It gives a magnesium oxide. To balance, we took 2 here in LHS also, in RHS also. Okay, how many oxygens are there? Here also 2. 2 ones are 2. Okay, next, iron with steam. Iron reacts with the water, it gives a iron oxide, Fe3O4, with a liberation of hydrogen gas. Calcium reacts with the cold water. Why does calcium float on water? Calcium Ca, it reacts with the water. What it gives? It gives a calcium hydroxide with liberation of gas. Calcium floats in water because the bubbles of a hydrogen has formed to stick the surface of the metal. Surface of the metal. Next, second question we have to see. A student was given a few grains of magnesium, iron and copper. She put them separately into test tubes. Which of these metals do not displace hydrogen acid? Okay, copper does not displace hydrogen from the acid. Hydrogen from the acid. Next, forms a pale green colored compounds. Iron forms a pale green colored compounds because of rusting. Then C, will give a hydrogen gas with dilute acid. Magnesium gives a hydrogen gas with a dilute nitric acids. Copper will be displaced from a solution of its salts by other metals. Copper will be displaced from the solution of its salts by other methods. Now we are going to discuss about give reasons of this chapter. Give reasons of this chapter. Okay, yesterday whatever metals and non-metal, I think lengthy chapter. Okay, scoring chapter. 20 minutes we discussed multiple choice and 1-mark questions. Now already 30 minutes are finished. We discussed 2 marks, 3 marks, 4-mark questions. Now give reasons are there, and also some previous question paper diagrams and previous question papers things are there. A lot more to discuss in this chapter. That's why this is a part 2. Part 3 we have to discuss in next clip. If you feel these are useful for your exam purpose and to write a fair, okay, and to listen, if you feel these are useful, then share to your friends, keep your status, and tell them to your friends. Also subscribe, because maximum members, whatever the persons watching my videos, those are unsubscribed people. If they subscribe means whatever the videos I prepare, those all notification come to them. So please subscribe. Thank you so much.